So this is your final assignment or assessment of your gravitation skills. That is your ability to attract others to yourself, or something like that. Okay. So make sure you look at the point values. The point values are a pretty good indicator of how much work is required for any given question. Okay. So for question number 1, you're told how far Jupiter is from the sun, and you're told its mass, and you're looking for the force of gravity between Jupiter and the sun. Not an overly difficult question. Okay. For number 2, there's more than one way to solve that question. Either way is fine. Okay. We know that Uranus requires 84 years to circle the sun. It has a mass of 8.80 times 10 to the 25, and that should say kilograms. Okay. After it, okay, we want Uranus's orbital radius for that one. So a bit of algebra to do on that one. Also remember what units we need orbital period to be in. Okay, Venus has a period of revolution of 225 Earth days, and the distance between the Sun and Venus is 1.08 times 10 to the 11. What is the orbital speed of Venus? Okay, also another one that could probably be solved more than one way. Okay. Number 4 is talking about the Cavendish experiment. We watched that video of the professor who set that up with the bowling balls and the masses on the ruler. Okay, so he used that to find G with a large lead ball and a small one. Okay, told us how far their centers are apart. Find the force of attraction between them. Again, not a difficult question. Don't overthink it. Okay. Number 5, the gravitational force between 2 electrons 1 meter apart is 5.54 times 10 to the minus 71 newtons. Okay, find the mass of an electron. There's a little algebra trick to that question, but once you get it, you'll realize why that question is only out of 4 marks. There's really not a lot to do. It's more of a realization question. Okay, the tip that I will give you is this: electrons all have the same mass. Electrons are all identical. Okay. All right, number 6. Mimas, a moon of Saturn, has an orbital radius of 1.87 times 10 to the 8 meters and an orbital period of about 23 hours. Find the mass of Saturn. Okay, so think about what it means if something's orbiting something else. Okay, number 7 is probably the trickiest of the satellite questions. Okay, a couple of things you need to watch for. You are given the orbital radius, or you're given, the orbital distance, okay, of 111 kilometers, okay, and you're told the radius of the moon is 1,785 kilometers, and you're given the mass of the moon. So this number here is measured from the surface, okay, 111 kilometers from the surface, okay. So we are looking for how many minutes it took to orbit the moon and the velocity of Apollo 2, okay, as it went around the moon. Okay, for number 8, a spy satellite has an orbital radius of 2 Earth radii. That is center to center. Okay, what is the period of revolution? So we're just looking for period on that one. I'm going to lay this out there simply because I don't want to be asked this question. The spy satellite is orbiting Earth. We don't spy on anybody else. Okay? We don't spy on Mars. We do scientific research. Spy satellites only have to orbit Earth. Okay? So it's orbiting the Earth at 2 Earth radii. Okay? Just because I have people come up and go, well, what planet is it around? I don't know. Okay? All right, number 9, you got Mars and its 2 moons. Okay, you're given the mass of Mars, okay, and you're asked to find the orbital speed of Deimos and the orbital speed of Phobos, given both of their orbital radii. Okay, so should be able to do that satellite question, no problem. Number 10, we may or may not have done one just like that yesterday. We totally did. Okay. All right, number 11, so we're looking for, for number 10, we're looking for the net gravitational force on this mass here. Okay, net force of gravity on that mass. Number 11, okay, asteroid has an orbital radius of 4.8 times 10 to the 11 meters. In case you're wondering, that's from our sun. Okay, and a mass of 1.4 times 10 to the 18 kilograms. What is its period of rotation around the sun? Okay. And number 12, Saturn has an equatorial radius of 6.0 times 10 to the 7 and a mass of 5.67 times 10 to the 26. I want the acceleration due to gravity, or the gravitational field strength, okay, on that, at that point. And then I want to know how many times greater a person's weight is on Saturn compared to Earth. Okay, so that is a gravitational field strength question. And for number 13, okay, the mass of one small ball is 0.00150 kilograms, the other is 0.870 kilograms. Their distance apart is 0.1 meters. Find the magnitude of the gravitational force between them. Don't overthink that question. It's basically as easy as it sounds. Okay? All right, questions from you guys? All right, Tyler.
What does it do?
I haven't decided yet. I'll put it up here shortly. Okay, any other questions? Okay, realistically, guys, you've got like the whole period for this. Just like your circular motion assignment, you should get pretty close to done if you stay focused. Due date for this, guys, December 12th. Okay, that is Tuesday. I know that's a quick turnaround, but you got the whole class today to work on it, and I want to be able to mark it and give it back to you so you can use it to study for your test on the 14th. Okay, so December 12th, that's Tuesday. That's still 3 school days. Now we say my minimum is 2. Plus you got a weekend in there, so okay, you got lots of time to get it done. Okay, so that 2 does not affect your significant digits. It's not a measured value. Okay, and secondly, if you're using numbers from the back of your formula sheet, like the mass of the Earth, the mass of the Sun, Earth-Sun radius, all that stuff, those are absolute. Okay, they're not measured values for us. They're absolutes. So only measured values from the question count for your significant digits. Okay. So as an example, okay, any number you're given in here, like this mass of Mars, that counts. Okay. This distance here, that counts. Okay. Those make a difference. Those are given to you in the question. You assume those are measured values. Anything from your formula sheet is considered absolute. Okay.